In this video, we're going to be talking about NumPy's arrays and some basic manipulation. So here's the code to create a basic array. This is a 1D array. You could see that it's a list within this NP array function. And then there's a 2D NumPy array here where we have these brackets, 1 and 2. And then there's 3 elements within the brackets. So that's what makes it a 2D array. And if you see this clearly here, this is a 1D array, 2D array. So that's fundamentally the building blocks for arrays. So this is a way to look at it. Now, there is a more complicated array structure. And I'm going to show you right here. So here you have something where you have 2 matrices. I'd like to call them matrices. That's not the formal definition, but it is a matrix. And then you've got 2 rows. And then you've got 3 columns, which are the elements within that each row. So we'll check its shape. We're going to be looking at a little bit more in depth shortly. We've got 2, 2, 3. So again, 2 is the number. 2 is the number of matrices which we have here. This is the first one, this row in its entirety. And then the second. Then we've got 2. 2 is the number of matrices which we have here 1. This is the first one, this row in its entirety. And then the second, 2 rows, which are basically these bracketed things right here. And then we've got 3 elements within each row, 1, 2, 3. So that's how you arrive at that. Here's a shape. So we looked at the array of flat array, right? Let's look at the shape. This is what you would get for a 1D array. And this is what you would get for a 2D array. And then you saw what you would get for a 3D array. Now here's another array shape example. 10 rows, 2 columns. That's the way I like to read it, rows and then columns. So we've got 10 rows, which is these bracketed things. And then 2 elements within each column. We could examine the data type of the elements. For the matrix, it's integers. And then the total size of the elements and the matrix dimensions, which is 6, right? We've got 6 elements, if you recall. 6 and the number of dimensions is 2. Now, there's something called view and copy behavior. And it's basically copying or getting a subset of the data, like looking at it. We have this large data set. We use this view function. We get a subset of it, and then we replace it with -1. You could see from this behavior, though, that what's a little bit strange is that when we modify this subset view, this gets modified as well. You could see this -1 that's coming out from the large data and then from the view data. So that's the behavior, like a little bit of an idiosyncratic behavior of view. We could do this something similar with something called copy. Now the copy array, it changes, but the original copy doesn't. So the original does not change. And this is something, you typically only use view and copy if you want to, just work with a subset of your data. And you don't want to, do data processing on the entire data set, right? Maybe you want to take a subset and see if your ideas work on a subset. Play with that because the time it takes to run code is a lot shorter, given when you would run your entire data set. So here's another example of another 3D array. This is 2, 3, and 4. So again, when we say 2, we mean like 2 matrices, right? 2 blocks, 3 rows. You see these bracketed things 3. And then there's 4 elements within each row, 1, 2, 3, 4. And then we do the shape, which is 2, 3, 4. Now we're going to be talking about H stack and B stack. And this is basically a data manipulation tool where you could either add data row-wise or column-wise. So when we look at H stack, okay, as an example, we see that we've got something where we've got these 2 rows and 3 columns, but 2-dimensional array. Now we multiply 2 times the original one and we stack it. We stack it this way. So now you see basically this row being added to the multiple of itself. So it's 1, 2, 3, 2 times 1, 2 times 2, 2 times 3, 6, 2, 4, 6. And then we've got another row where we go 4, 5, 6. And we stack times 4 times 6, which is 8, 10, and 12. Now we're going to stop this way, where we're stacking it vertically. I'm going to be talking about this in a little bit. But so to continue, basically, now we stack it row-wise. Here we were stacking column-wise, right? 1, 2, 3, 2, 4, 6. Now we're stacking row-wise. Remember, this bracket thing is a row. So we do 2, 4, 6, 8, 10, 12 this way. Now what is it used for? I mean, in machine learning or regression, you have a predetermined set of variables that you want to use to predict the dependent variable or the label, as a machine learning people like to call it. But say you, for example, have age, but you want to age to the variable to see how much is the salary. That's what you're trying to predict. I'm not salary. Maybe what area you live in, because I've just got income here. You could add income also as a variable. So you would want to add another column. And that's what it's doing. So you've got age here. Right. You've got 3 rows here, and then you've got 3 rows here, but there's 1 column. So you're adding 1 column to 1 column, and that's what you get. So you've got the age here, and then the income in this column. So you would add more features to basically improve the prediction power of your model. And that's the way you would vertically integrate another variable that might help in your prediction power. Now, we could add, like I showed you the V stack where we added in it, row wise, and that's what we want to do if we added more data to our already existing population. So for example, in this one, age and income, let's just make a number up. We have 100. We could add 1 more row of age and income. And you would stack that 1, 2, 3, 4, and then 5, 6. This is your new data point. Increasing the sample size. This happens all the time. You know, like in e-commerce, for example, if there's a new order for like a particular product, it gets logged into the CRM. You're adding rows of that particular product. So it's a very fundamental idea. It's a very fundamental idea in terms of how you look at data. Now we've got something called H split and B split. H split splits this into 2 matrices, if you want to call it, into 2 equal parts. So it'll take 3, 4, 6, 7, 5, 2, and 2, 6. The split does this. It splits it into 2 different arrays. As an example, say you've got feature in label data. So before we were looking at features like agent income and then how that might predict what neighborhood you live in, which is the label. You could split 0 being the label. You could split this into the features and then the labels. So if I run this, I get 5.1, 3.5, 1.4, 0.2 up to this point. The labels would be 0 or 1. If I ran this labels, it would just be 0. So it would be taking this off. So that's a useful function to basically separate those 2 things. And you're going to be seeing a lot of that in machine learning in general. Maybe not using this particular function. I mean, in Scikit learning, they've got some to call train tests split. But it's that idea is driving that algorithm as well. Here we did a features and labels. Now let's try to do train and test. So I do the train here. We're training the data on 5.1. All of this. The labels are included. Right. So in the previous one, we separated the labels from the features. And then here we're separating it. So let's try to draw wise, right? Where this is the training data and the test is the last row here. Now we're going to go on to something called expanding dimensions, which is np.expanddims. And let me just run it now. It's here, we get this. We get 2 brackets here. Now if I did temp.shape, you could see it's 1 and 12, so it's 12 elements. Now what if I did ar.shape? You would just see this, which means it's a 1D array, and we did this along axis is equal to 0. So going back, let me just keep this 112. Now this is different. Recall, you could see that there's one element within each one row. So I mean, if this was consisting a row, this is an element, right? And there's going to be 12 of these rows, right? When we saw this, we saw that the shape was 112. This would be the exact opposite here. So you see that they're different. I have this -1 here because I've seen it before, and it does practically the same thing as the 1. I don't see a difference. If we compare it element by element, it seems to be the same. So why do we need that? Because which is a very popular machine learning package, only accepts 2D arrays. It will not accept a 1D array. And the 2D array represents number of samples and number of features. So if I run something like this where I set access is equal to 0, see the original dimension of the array is 3, 1, but the transformed array is 1, 3. So that's an important point to make, is that when you use machine learning models, it will not accept a 1D array. It will accept 2D. So thank you very much, and I'm going to see you in the next one. And we'll be talking about array indexing and slicing.